Okay, class, we finally made it to the last section in Chapter 4, and we're going to see this is another type of story problems, and all the story problems deal with area in some way or another. Now, I have to make an assumption. I have to assume that you know formulas for area, but I will tell you this, the two that we are going to use the most is the area of a square, and remember, what do we know about the sides of a square? Yeah, they're all the same size, and so the area for a square is s squared. We know we would say length times width, but each side is the same measure, so s times s, and now that we're in Chapter 4, we know that s times s is s squared. And the other formula that we're going to use a lot is the area of a rectangle, and I'm pretty sure everybody knows that one as length times width. So if you look at my picture up here on the slide, just be an idea of what we're going to be doing. If I showed you this picture and I said find the area of the shaded region, okay, if you notice I got a green rim on the outside and white on the inside, how would we find the area of that shaded region with the information given? Yeah, that's right. If you look, we can figure out the area of the larger rectangle. We've got the length and the width, and so we would say 12 times 10 is 120, and inches times inches is inches squared. And then we can find the area of the smaller rectangle. We've got 4 and 3 as the length and width. 4 times 3 is 12, and we can subtract that. So minus 12 inches squared, and then 120 minus 12, our final answer would be 108 inches squared. Now we're going to kind of use that same idea as we go through and look at these different area problems. Now we've got 3 different scenarios, and we're going to look at one of each. So scenario number 1, it says, a painter paints 2 portraits with the same area. One portrait is a square and the other is a rectangle, which is 4 feet longer than the square and 3 feet less wide than the square. What is the area of each portrait? Okay, so go back up to the first sentence. Very important word that we saw back in chapters 1 and 2. That's right. It says that they are the same area. And we know whenever I see something that says the same, that means one is going to equal the other. So one portrait is a square. How do we find the area of a square? Well, we just talked about that. It's going to be the side times the side, or s squared. Now, let's look at our rectangle. It says one portrait is a square and the other is a rectangle, which is 4 feet longer than the square. So if the square is s, this is going to be 4 feet longer, so that would be s plus 4. And then it's 3 feet less wide than the square. So if the square is s, okay, then this is going to be s minus 3. Makes sense. So you've got to be able to go through and be a good detective, find those clues, and decipher what the words are saying. Now, the question is, what is the area of each? Well, because they have the same area, we know that the square, the area of the square, is going to equal the area of the rectangle. I guess I better put an L in there. A rectangle. All right, so what's the formula for area of a square? Well, we've already said that's going to be s times s, which is s squared, equals the area of my rectangle. We've already said a rectangle is length times width, so this is going to be s plus 4 times s minus 3. Now, here's where we got to stop for a minute and think. You've got to be able to multiply those binomials. A binomial times a binomial. Well, how did we do that? Do you remember? Yeah, we said there were 2 different methods. You could either use the distributive property method or you could use the vertical method. So everybody take a couple minutes and let's multiply out these 2 binomials. Now I'm going to use distributive because I got some room up here. So remember, we're going to take the first binomial part, s, and multiply by s minus 3 plus 4, and then s minus 3. So we've got s times s is s squared minus 3s plus 4s minus 12. Remember, we're going to be able to collect like terms in the middle. So we're going to end up with s squared equals, and if I look there, and I collect like terms, we're going to have negative 3s and 4s. So we got s squared plus s minus 12. Okay, so this came from multiplying my binomials. So now where do we go? Well, remember, isolate the variable by inverse operations. Now, do you notice we have s squared on both sides? Well, we're still going to use those properties of equality from chapter 3. So I'm going to subtract s squared from both sides. Now, we usually say that cancels, but if something cancels, what is left? 0, that's right. So 0 equals, that cancels, and now I've got s minus 12. Okay, what would be the best move now to get letters on one side and numbers on the other? Yeah, we've already got s alone. We've got s here, so let's add 12, and then that automatically puts everybody where they need to be, so 12 equals s. Now, we solved the equation that we had, but now let's make sure that we answer the question. And if you remember, the question was, what is the area of each? So if I'm looking at the square, okay, we said s is 12, so the area of a square is s squared. So 12 squared is 144. And then what was our unit there? It was feet, so 144 feet squared. Now we've got to find the area of our rectangle. Well, remember, that's length times width. So that's going to give me s plus 4 times s minus 3. Now when I plug in a 12, we've got 16 times 9. Guess what 16 times 9 is? 144 feet squared. And then for your check, you can just say 144 equals 144. Okay? So that is scenario number 1. Now, let's look at the second type of area problem that they can give us. Let's look at number 2. It says, a rectangle is twice as long as it is wide. If the length is decreased by 4 and its width is decreased by 2, its area is decreased by 24. Find its original dimensions. Now, first of all, if they're asking for dimensions, what are we trying to find? Yeah, that means they want the original. Here's the original. They want the original's length and width. Now, do you understand what's going on here? We've got our original rectangle, and we're going to take it and make it smaller. Okay? So, we kind of go back to some strategies we learned back in chapter 1. If we look at sentence number 1 here, it says a rectangle is twice as long as it is wide. Okay, so we know then that last shall be first. So the wide is going to be W right there. And then if the length, okay, the length is twice as long, so that's going to be 2W. So that makes sense. Now, let's look at the second sentence to talk about when we make our rectangle smaller. If its length is decreased by 4, well, we're taking its length and decreasing it by 4, so that means this is going to be 2W minus 4. Okay, and we're going to take its width and decrease by 2, so that means this is going to be W minus 2. And its area is decreased by 24. So when we made it smaller, we're going to decrease it by 24. Okay? All right, decrease by 24. So now, how are we going to figure out how to write the equation? Well, we've got the area of the bigger one. How do we find area of a rectangle? Length times width. So we've got W times 2W. And we made it smaller by 24 equals, okay, the smaller rectangle. How do I find the area of the smaller rectangle? Well, it's length times width, so that's going to be 2w minus 4 times w minus 2. Now look at that. Does it make sense? Okay, we took the area of the original, we decreased it by 24 to get the area of the new smaller rectangle. Okay, so what do you think we need to do next? Yeah, we've got some multiplication to take care of. So if I go and take care of the multiplication, let's see what happens. We've got w times 2w, which is 2w squared minus 24. Now, over here, are you going to use the distributive method to multiply these guys? Or are you going to use vertical? I'll use vertical this time because I've got a little bit of room right here. We've got 2w minus 4 times w minus 2. Remember how we did this a couple days ago? It's going to be w times 2w, which is 2w squared. And then we go back and multiply w times negative 4, which is negative 4w. Okay, we multiplied the top line by w. Now we've got to go back and multiply everybody by negative 2. So negative 2 times 2w is negative 4w. Look where I put it. We put like terms in the same column. And then negative 2 times negative 4 is positive 8. Remember, then we just add our columns. All right, so I multiplied those guys together, and here's what we've got. We've got 2w squared minus 8w plus 8. What do you think we should do next? Yeah, did you notice those 2w squareds on both sides? So let's use our properties of equality and get rid of them, because what I do to one side, I do to the other. So we're left with negative 24 equals negative 8w plus 8. All right, isolate the variable by inverse operations. Who's my floater? Yeah, we're going to subtract 8 from both sides. What's negative 24? Negative 8. Negative 32 equals negative 8w. We got to divide both sides by negative 8. So w equals 4. Now let's just see something a minute. When we're figuring out these area problems, our answer should be positive. If you get down here and you get w equals a negative number, you made a mistake because length and width can't be negative numbers. All right, so we got 4. So we finally found the answer to the equation. What was the question they're asking me? Well, if you remember, the question said what the dimensions of the original. Okay, so if I need the dimensions of the original rectangle, remember that's length and width. So width equals 4, okay? And again, since they didn't give me units, we'll just say units. And then for the length, if you remember, that was 2w, if you go back and look at our drawing. And so that means that's going to be 8 units. All right, and somewhere in there, you need to give me a check. All right? Somewhere in there, you need to give me a check and make sure. Okay, so that's scenario number 2. Now, let's look at the last scenario as we go through here. It says, Hector built a square fish pond surrounded by a brick walkway 2 meters wide. He had enough bricks for the area of the walkway to be 40 meters squared. Find the dimensions of the ponds. Now remember, I like for you to draw pictures because a picture's worth 1,000 words. So here's my picture. I've got my pond in the middle, okay, and I've got my brick wall around. All right, so remember it says we've got a square fish pond. So if I look at the blue part, which signifies the water in the pond, if it's a square, how do I find the area of that? Yeah, it's going to be S times S. Okay? Now, if you notice, we built a brick wall 2 meters wide around. So if you notice, I've got 4 sides around my pond, and I made each one of those 2 meters wide. Okay, so this is 2 meters, this is 2 meters, and this one is 2 meters. So we've got the pond on the inside, and we've got the brick wall all the way around. Now, it said he had enough bricks for the area of the walkway to be 40 centimeters, And we've got to find the dimensions, the length and the width of the pond. So if I look at this, what do I know? Well, if I'm looking at the whole picture, okay, we know it's got to be the area of the pond plus the area of the walkway, okay, is going to equal the total area of Hector's backyard oasis. Okay, so let's see if we can figure this out. How do I find the area of the pond? Well, we're looking at the red letters, and that's easy. That's S times S. Okay, now, what was the area? How do we get the area of the walkway? Well, the area of the walkway was actually given in the problem. Remember, we saw that was 40 meters squared. Equals the total area. Now remember, area is length times width. So let's go over here and look at our drawing. I want the total area, so that means I've got S plus I've got 2 meters on one side of the pool and 2 meters on the other side of the pool. So that's going to give me S plus 4. And that's going to happen also when I look at the width. We've got S plus 2 meters on the front and 2 meters on the back. And so that's going to give me S plus 4 as well. So that means that the total area then is going to be S plus 4 times S plus 4. Okay, so let's go ahead and do a little bit of multiplication here. So we've got S squared plus 40 equals, let's multiply these two binomials together. We're going to end up with S squared plus 8S plus 16. Promise. Okay? So now, where do we go? Yeah, those S squareds are the same again. So we're going to use our property of equality and get rid of them. What I do to one side, I do to the other. So 40 equals 8S plus 16. Who's my floater? Yeah, we're going to subtract 16 from both sides. And when I do that, we have 24 equals 8S. And if we divide both sides by 8, what does S equal? Yeah, S equals 3. All right, we finally looked at our picture, made our equation, found S. But what was the question? Okay, well, the question was, what were the dimensions of the pond? Well, if we look back up here, the pond is S times S. So that means that our dimensions of our pond are going to be 3 meters by 3 meters. So there's the answer to our question. All right, and somewhere in here, I need a check. So let's go ahead and look at it. Okay, I'm going to use our original equation. So if I plug in a 3, we've got 9S squared plus 40 equals, and we've got 3 plus 4 is 7 times 7. So we're going to get 49 equals 49, and it checks. Okay, so 3 different scenarios using area. You may start your homework. Good luck.